Hi everyone, welcome to the another video of IAL Edexcel Physics Unit 3 Model Answer, June 2017. This is question number 1. Which of the following is an SI based quantity? 4 options are given. Remember, they are asking SI base quantity, not the unit. Because if you see, we have ampere and we have a current. Ampere is SI base unit, while current is SI base quantity. So our option is C. Question number 2, a student measures his reaction time. He takes the following reading. Which of the following should be stated as mean value of time with suitable uncertainty? A typical question. This is 0.09 second, 0.2, 0.1, 0.21, and 0.09 is not taken, is not considered because it's out of range, it's an modulus reading. So how do we find the mean value with uncertainty? First of all, we need to find the mean, and mean of these two number, mean or average value of these two number, 0.19, 0.2 and 0.21. Of course, if you find the mean, adding these three divided by 3 and you will get 0.20. Second, this is mean, and for uncertainty we need to find range and then divided by 2. So if you find the range, highest minus lowest value, it will give you 0.02 divided by 2. Uncertainty would be 0.01. So you can combine the mean value with the uncertainty, and you can write the mean value with suitable uncertainty is 0.20 plus minus 0.01 second. So your option is B. Yes. Okay, to determine the viscosity of the liquid, a sphere is timed as it dropped through a column of the liquid. To determine the viscosity of the liquid, which of the following is not needed? The density of the liquid, the density of the sphere, the diameter of the sphere, the volume of the liquid. So we need densities because in sometime we need upthrust equation to use. So we need density of the liquid and density of the sphere as well as diameter of the sphere. So option is we don't need a volume of the liquid. Question number 4, which of the following instruments should be used to measure the diameter of the sphere? So because the sphere is very small, so the best option is micrometer screw gauge. Which of the following is the SI unit of for viscosity? Yes, viscosity. So if you see the let's see, Stokes law says F is equal to 6 pi eta RV. Okay, so if you rearrange for viscosity, so eta will be F over 6 pi RV, and then 6 pi eta has no unit, so you can say this is Newton meter S minus 1, and if you rearrange this, it will give you Newton meter minus 2 and second. So Newton second meter minus 2. So option is B. Let's see the next question. Okay, you just read the question after pausing the video and then we'll start. Okay, so explain why the wavelength of the microwave is equal to the twice the distance between the burn mark, and they are saying that the student measure the distance between two adjacent burn mark is 6 centimeters. So if you take this and this as a burn mark, that means these are maximas. So you can say that, so this is one antinode, this is another antinode. The distance between two antinode, we know that this is lambda by 2, and the distance measured is 6 centimeter. So you can say that d is equal to lambda by 2, and lambda is equal to twice of the d. So lambda is equal to 12 centimeter. So that means twice of the major distance. Next part, calculate the speed of the microwave. So we have formula f lambda is equal to v. This is frequency given. Wavelength we have already found, which is 12 centimeter. So you can find the velocity. V is equal to 0.12, which is the wavelength, times 2450 into 10 to the power 6. It's because of the million, or you can say mega. So V is equal to 2.94 into 10 to the power 8 meter second inverse, and it's okay because the speed of electromagnetic waves is 3, so it's around 3. Part B, suggest a suitable instrument for measuring the distance between burn mark. Give a reason for your choice. So the suitable instrument, because the length is 6 centimeter, so it's a meter rule, because the least count is, or you can say because of the precision of 0.1 centimeter, the suitable instrument is meter rule. Calculate the percentage uncertainty in 6 centimeter distance when measured with your choice of the instrument. So percentage uncertainty. So percentage uncertainty is 0.1, which is the precision, divided by the measured value 6.0, and it will give you 1.66. Yes, multiply by 100. Okay, and it will around 1.7%. Question number 7. A student is asked to determine the resistance of a 12-volt filament lamp at a different potential difference. Plan an experiment to do this using graphical method. Okay, so labeled circuit diagram would be, so circuit diagram is, we need to use a bulb, voltmeter, ampere meter, and variable power supply, or we can use variable resistors, and a battery. And that's it. So the idea of a circuit diagram is, we put bulb, ampere meter, resistor, and battery in series. So let's see, the bulb connected with the ampere meter, then ampere meter is connected with the battery, then battery goes to variable resistor, and then bulb. This is a closed circuit, and then rest of the component, which is the voltmeter. Voltmeter is connected parallel to the bulb. Okay, part B, state the quantity to be measured, suggesting a suitable measuring instrument for each quantity. So because we will be measuring ampere meter, we will be using, yes, ampere meter to measure the current. So the quantity to be measured is, the first quantity would be current, and we use ampere meter of range of ampere meter should be greater than and equal to 12 ampere. And the second quantity is, we are going to use voltage or potential difference. In order to measure voltage, we are going to use voltmeter of range greater than and equal to 12 volt. Comments on whether the repeat reading are appropriate in this case. No, because of high temperature of the bulb, or you can say the bulb will be hot after passing some current, so it's not suitable to take the repeat reading. Sketch the graph to be drawn and explain how the data collected will be used. Okay, the sketch is, one option is we can plot the graph between I on the y-axis and I on the y-axis and V on the x-axis, and we can expect a curved graph like that, and we can take the gradient at any point of V and then take the reciprocal of gradient will give us the resistance. So you can say the resistance would be 1 upon gradient at particular voltage. Identify the main sources of uncertainty and the systematic error. So you can say that the first option is, if you are using analog meter, in case of analog meter we can have zero error, and the second is, it's difficult to measure V and I simultaneously. Command on safety. So because of DC current or low voltage, there is no risk of but no risk, but bulb is hot to touch. Okay. Yeah, sorry, I don't have another page, so it's just a little messy, but I hope you will get the idea. This is question number 8, and it's all about the Young modulus. A student investigating how the extension delta x of a wire varies with the applied force. So a table is given. Mean diameter of the wire is 0.245 millimeter. Regional length is given. This is the table. Criticize the result. Again, it's a typical question, criticizing the result. We have some pet sentences. So for example, if you see we have a inconsistent significant figures, we have a two significant figures, sometimes uh, three significant figures, so we can write like 2 and 1 here. So we are using um, or the student is using inconsistent significant figures, and you can say uh, no repeat reading, no take mean values taken to in order to avoid random error, and yeah, 2, 4, 5, 6. We have a large gap between 600 and 1000 gram. We can write these points. So no repeat or mean value is shown. Inconsistent significant figures, large gap between 600 and 1000 gram, no low range masses are used. Describe how the student should measure the diameter of the wire. Of course, when we use diameter of the wire, so we take care of the wire that we must take the reading from different places in order to remove the random error. So we use micrometer screw gauge and find the diameter from different places and take the mean value, so we can remove the random error. Plot the graph of f on the y-axis against delta x on the delta x on the x-axis, and grid provided. Okay, so here from the table which was given at the start of the question, on the x-axis I'm going to take delta x, and here I'm going to take force in the Newton, and I will say that it's easy 1 and 2, 3, 4, 5, 6, 7, and so on. And on the y-axis you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And if you plot the points as per the table, you can get this type of graph. So delta x is in centimeter, force in Newton is the point, and this is the graph. So from 0 to 5 point something, I guess 5.9, is this a straight line, and then it starts curving, showing the plastic behavior. Comments on the shape of the graph. So this is the comments, this is the graph. Graph is a straight line showing elastic behavior, and after that after 5.9 Newton it is permanently deformed and showing a large plastic deformation. Use your graph to determine the Young modulus of the material the wire is made from. If you need to find the Young modulus, so Young modulus is Y is equal to sigma stress over strain, and if you use the stress and strain formula, or value force over, so you can say stress is F over A, and strain is delta X over X. And if you rearrange, you can have Fx divided by A delta X. That means I have area, I can find area because diameter is given, delta X is okay, X is given, yes, of course original length is given at the start of the equation, but I need F or delta X. Okay, yes, fine. Here that means I can rewrite this equation as y is equal to k x over a. Why did I write k here? Because if you see, F over delta x, this is your stiffness, k. Stiffness. And stiffness can be found from the gradient of the graph. From the gradient of the graph. That's I'm going to use the gradient from the graph. So from the graph, if you find k, so k would be equal to 10.8 minus 1.96 divided by 6.4 and minus 0.3. So k would be equal to 1.449, approximately 1.5 Newton per meter. This is my k, and then I can use this k in this equation. So y is equal to, okay, first at the start, diameter is given as 0.245 millimeter, and original length x is given as 1.35 meter. Okay, using diameter I can easily find area as pi r square. R is the radius, half of the diameter, and then I can use area x and the value of k. I can use, this is k, this is x, and this is area in this equation to find the Young modulus. So if I do all the calculation, so the Young modulus, most probably I will get 42.95. I'll round it off. Young modulus is 43 mega or million Pascal. That's it for this video. Thank you very much to watch it. See you next time.